Hi guys, and welcome back to the channel. So today we're going to be reviewing or taking a look at the Eachine Wizard. Now this is new from Eachine, and it seems like it's going to have a lot of potential, and as you can see they kind of got inspiration from the Hyperlight floss frame. However, there's a lot of differences here. This is a lot thicker, it's a lot heavier, and it's just overall different layout. So, one thing you need to take note of, they did also copy the same type of factor, and this is not a true X or a stretched X. This is an H-type frame. As you can see, it just looks like an H basically. The motors will not align with each other, so that's something to take note of. Another thing, what we're going to do today is a lot of people are complaining of huge latency in the FPV footage. So we're going to take a look at that. We're going to actually measure the latency with and without this HD recording device here. So that's one thing we're going to be doing today. Another thing, we're going to actually remove these ESCs with the motors, and we're going to run some noise testing on. Now, I did watch UAV Future's video, and when he put the 6S, you could totally hear it was the motor popping. It just sizzled. I'm pretty sure it was a motor that burnt on his quad. It wasn't an ESC. However, the motor burnt and then it just went back. Possibly burnt the ESC also. So the ESCs should be able to handle, but the motors are the ones that are not able to handle the 6S. So take that into consideration when you get this. Possibly even a 5S, you might be pushing it. Now, looking at the motors here, I do see it just, the clearance between the magnets and the coils is very good. It's very small. I can guarantee you they're not any Racerstar rebranded motor or anything of that nature. They actually seem like Sunny Sky probably did these motors for them. It's kind of the same style they go for. Now let's go ahead and move on to the ESCs. Now the ESCs are pretty spectacular for such a budget quad. Now these are TS215 ESCs. They have RGB LED, as you can see right there. They do have some nice filtration. They have telemetry. They have current sensing. They have temperature reading. They have RPM reading. They seem like a pretty good ESC, to be honest. However, that's what we're going to do today. We're actually going to rip this off and test it. So we're going to go into that in a bit. And as you can see here now, if we move in, you can see that the ESC is connected to this proprietary AIO all-in-one flight controller. This is an F4 Omnibus. And as you can see here, it has the PDB built in. It does have a lot of functions. I really don't like this. Now, one thing I wish they would have done is add a telemetry pad. That would have been absolutely awesome right there, but they didn't, so that's it's alright, I guess. We could do that ourselves. Alright, so moving up on the stack, we have this thing here. Now this is adding extra weight, and it's adding all the latency. This is the Dvr Footage Recorder. So in theory, because you cannot fit a GoPro up here, you would stick an SD card here, and you would be able to record your footage. However, this is adding a ton load of latency, and we're going to be testing today exactly how much latency through the oscilloscope, how much latency this has. And I do highly recommend you remove this piece, and if Eachine's watching, please remove it on the newer models. I don't think there's a need for it. Maybe give us some nice 3D printed something for the GoPros up here. Now, the VTX here is pretty interesting. It's a 72 channel VTX up to 800 milliwatts. It does have a microphone right there. It doesn't say anything about pit mode or anything, but as you can see, it does have some nice filtration up here, and it does have a BEC on board, so that's possibly powering the camera here. So we will take it apart in a little bit and take a look at everything in here. And as you can see, mine came with the XM Plus radio, and the execution of this whole setup is very nice. Like absolutely clean, and I really like it. It just looks absolutely sexy. Some people might hate it, but I really like the looks of this. It's just looking absolutely insane. Now, I'm not going to be able to fly for possibly a week, so this is the reason why I'm doing a teardown and a testing of the components that are on board of this quadcopter. Our current weather is very terrible, and it's impossible to fly or get the actual performance of a quadcopter, so there's really no need for me to go out just yet. Alright, so the camera here, they're stating it's a CCD 1200 TVL line. However, I really don't think it's a CCD, but I will be able to figure it out through the oscilloscope, and I could actually tell you if this is actually a CCD or a CMOS camera. So I mean, that's pretty much it. That's going to conclude it for right here. So let's go ahead and start taking this guy apart. So I'm going to go ahead and remove the upper plate now. It is very nice. Look at this. This is for easy access. This adds weight, but I really like this actually. We're using an XM Plus radio. These come in two versions, plug and play and with the XM Plus. I chose the one with the XM Plus here. So let's take a look at this right here. So this is the VTX obviously. So let's go ahead and start removing this guy also here. Alright, so I have the nylon nuts basically removed now, so let's go ahead and just start easily taking this guy out and taking a look down below. So let's just see how everything is routed here. Alright, so here we have an MMCX on the VTX. It is a 870TX It does have smart port. Oh wow, I didn't even know that. That's pretty crazy. It has 5-volt regulator for the camera, ground, video, ground, and the input, which is 7 to 24 volts. So that's pretty cool. So let's go ahead and pop this guy off real quick. All right. Okay, so here we have our wires that are coming, I believe, from the all-in-one flight controller, which is the PDB and the flight controller, as well as the recording device here, the recording component, which you should just really forget about. So let's see how everything is wired up here. As you can see here, they removed some kind of a port just to fit that nylon nut in there. So one thing to take note of is that the standoffs, the nylon standoffs, are actually tightened down pretty good, which is really rare sometimes for pre-built quads. Maybe the employees get lazy and then they stop doing that, and that creates a lot of issues. And when you lose nylon nuts and then your flight controller is going crazy, you get all these oscillations, you crash, and that's it, you break your quad. So you have to take that into consideration. That happened to me with the awesome F200, the Pro Edition. I broke the VTX port pad, so I had to redo that. So yeah, take that into consideration. All right, so let's take a look here. All right, so this is the recording device, and as you can see here, it has, I believe, a 5-volt, because it's powering up the camera right there with this little connector right here. And here, what do we have here? Where is this coming from? So let's actually see if we can, oh, that's awesome. All right, so this wire is connected to, all right, so we removed the camera. So let's just remove this one also just out of the way here. All right, so the camera was connected to this board right here as it was powering it up and doing everything for it. So let's take a look here. What do we have here? It's not really saying much, but what I think this is going to, possibly, I could be wrong, obviously power and ground. And we have another wire here, which could be to enable the recording, maybe. I'm not really sure. I have not tested it. So yeah, so well, I mean, it makes everything easy for us, to be honest. So let's remove this here. Oh no, I know what this is. This is power, and this is gonna be the green wire is gonna be the wire that's going to the VTX here, which is giving the video feed. So yeah, that's what that is. It's not to record or to enable recording through the OSD or anything like that. So now we know what this is for. This wire is for here. All right, so let's take a look at the flight control. Now we're not going to need this for right now. And what is this here? All right, so this is the VTX. I'm going to keep the VTX just on the side right now. And this is for our receiver here. Okay, so let's just take a look at the flight controller. Now, as you can see here, we do have current sensing, so that's pretty good. There's our little regulator here. We do have SD card expansion. The gyro is soft mounted. This is pretty strange because it's an MPU 6000 gyro. So possibly they did have issues because of the, how the all-in-one flight controller, or the proprietary flight controller here, is mounted to the, or bolted to the frame, so there's really not a chance to add any kind of dampening, and the vibrations could probably would just probably had oscillations that you could not have removed at all. So they did go ahead and soft mount the gyro, which is pretty interesting actually. And it is, you can actually remove it, and it's sitting right on top of the microcontroller unit, which is the F4 chip inside. So that's pretty interesting, I would say. I mean, yeah, I think that's what I would say. So let's go ahead and remove this sticker because it's very annoying. All right, so here we have the USB port. We have a buzzer. This is our boot button here. There's our OSD chip right there, and there's our barometer right there, that little guy. This is for altitude hold. I'd never tried it, but you can possibly set it up. So basically it's on a specific altitude. This reads through the air pressure what altitude you're on. Some people say to put like a little piece of foam on top of it because of the wind can kind of mess up the pressure, and your quad can be going up and down quite a bit. I've never tried it, but this is what I've read and what I've seen. So take that into consideration. So it does have a barometer for altitude hold, so that's pretty cool. And that's pretty much it, really. There's nothing else here. All right, so here we have our reading right there. If you could see that. That says video in, 5-volt and ground. And if we take a look here, let's see if we can have, yes, we do. So as you can see here, what color is the video? Video is yellow. So video in here, so if we wanted to remove this piece right there, the HD recording thingy, what you would do is you're going to take the camera wire here, and in theory, let's see, because this is a 3-pin, we would have to remove these 3 right there. and remove these three here, and then actually insert them in the correct orientation. And now you can just stick your camera right there and it'll automatically take it to the VTX. So I'll show you how to do that in a bit. That's to remove all the latency. So right now what I'm going to do first is we're going to go ahead and start testing the latency with the DVR recording device here, component, and seeing exactly how much latency we have with and without it. So let me prepare everything and let's check it out. Alright guys, so we've taken the quad apart, and what am I doing here? So let's just talk about the methodology here. So what I have done is I've connected the cameras inside that box there with an RGB LED, and here we have the DVR. It's still connected. That DVR component is right there, and from the DVR it's going to the VTX, which is right here, but the VTX output is going to the oscilloscope right there, which is this top upper line, and there is the screen with the video feed. So currently it's black in there. And if you watch here, if I click this button, it turns white. And as you can see, the exposure starts to set in right there. Now, what we're going to do first is we're going to look here. I'm also going to have this screenshot right here, hopefully in this corner. So when the bottom line here is when the LED turns on. So when the LED turns on, then we start calculating from here till we actually see a change in the video signal. So you can see here, LED off, 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 off. But it turned on here, but then it registered all the way here. So let's take one sample right now together. So let's go ahead and do this. So let's go ahead and measure what it came out to be. So let's just zoom in here. And we have a delay of 63 milliseconds. Now let me go ahead and save this for you guys. So here we go. It's saved. All right, so let's go ahead and take another measurement now. So the worst I've gotten was 75 milliseconds, which is a long time. No wonder people are complaining. So let's see right here. So we're going to zoom in again. And this is 62 milliseconds. So it's about, so each one of these dips, as you can see those dips, each one of those dips is a half a frame. So half frame, so that's one full frame. And that's how it goes on. Now what I can tell you, this is really a CCD camera. It's not a CMOS camera. So this is a CCD camera right here, and that's for sure. Now the TVL lines, I've not counted those, but maybe I'll count them. I don't know. We'll figure it out. So here we got another one of 62 milliseconds, and I'm going to go ahead and save this. All right. So let's go ahead and take another sample here. All right. Okay, so let's just see this one. This one is around, I can't really see it, I think 64.8 milliseconds, so it's a huge amount of delay. For example, the Cadex camera, I'll leave a link down below, that thing was a 4 millisecond of a maximum delay. So right now this is with the HD recording component, or the DVR that's on the quadcopter. This is the latency with that installed. So now what I'm going to go ahead and do is save this real quick. And what I'm going to do now is I'm going to remove it completely from the setup here. So it's going to be directly camera to basically the VTX, and we're going to see the amount of latency difference. So we got in the 60s, I got a maximum of 75 milliseconds. It's huge, huge, huge amount of delay. No wonder people, or lag, or latency, no wonder people are really complaining about this, but they're saying its overall performance is absolutely spectacular. The motors look good, but the ESCs, they seem okay, but we're going to test that also in a little bit. So let's go ahead and remove the DVR component and see how it is without it. Alright guys, so now the camera is in by itself alone, which would be directly connected to the VTX here. So let's go ahead and just make a quick test. I'm going to go ahead and turn on the LED, and it turns on very nice. So as you can see, the OSD is gone because we're just testing the camera by itself. So let's take our first measurement here. Alright, so as you can see, the LED is off, and we have not triggered the LED just yet. And boom. There we go. So as you could already see, there's a huge difference right there. So let's take a look here. All right. That's 20 milliseconds. That's pretty insane, actually. 20 milliseconds. So that's just, it's a huge difference. As you can see, that's like, what, a third of the latency right there. So this is very good. So let's go ahead and take another sample and just get another idea. There we go. Let's zoom in. All right. That's 4.6 milliseconds. Yeah, there's a huge difference. night and day difference. The other thing was like 64 milliseconds to 75 milliseconds with the DVR. Without the DVR, it's reaching 4.6 milliseconds to, I think it was a 20 millisecond maximum. Anyways, we have it saved. I'll have it in the corner here, but let's just go ahead and take another sample just for the fun of it. There we go. Let's zoom in. All right, so let's just see a quick sample here. 12 milliseconds. So basically the delay of this is around I would say a full half frame. So that's anywhere between, I think they're using PAL, so PAL is around 17.5 milliseconds or 15 milliseconds, but up to 20 milliseconds, because we saw that 20 milliseconds basically skipped a full frame, which is 2 of those. But you know, that's on rare occasions possibly. Let's just take another sample here. All right, so we got 6 milliseconds there. Yeah, 6 milliseconds. So yeah, it's a huge difference, very big difference. So I'd highly recommend you actually remove that piece, and yeah, remove the piece, and you'll have a very good flying experience from what I have heard about this quadcopter. So now let's go ahead and move to the ESC. Now what we're gonna do is I'm gonna remove the ESCs, stick them on the bench, and test for noise. We're gonna do different throttle levels, and we're also going to do the custom noise injection script that I've usually been running on all ESCs. It's like a little stress test, which simulates flights and hard maneuvers. So let me prepare everything, and let's get started. Alright guys, so here are the testing results. Now I did have the exact setup as supposed to come with, which is the motor, the same ESC, as well as the props straight from the box, which are the Cyclones 5046, I think. So everything here is, you know, how the package comes together. Now we do see some very high voltage spikes and some very low voltage drops. Now it's okay, it doesn't mean it's crap. Let me tell you why. Because this is a 2306 motor. And you know, some 2306 motors with ESCs can have a 50 volt voltage spike. So that is the ones you really kind of want to try to avoid. So this is overall running pretty decent. I really can't say much until I fly it, but the ESCs seem a bit noisy actually. They do seem a little bit, they do have a lot of noise actually. However, you know, something very strange that happened with me. Now usually, you know, I connect everything, I run everything, everything runs perfect. However, for some reason, it would not want to run good. And what I had to do is I had to connect through an Arduino to the ESC and modify the ramp up power to 101%. It's default by 50%. So if you do notice weird jitters or your motor sounds really rough, then you're gonna have to increase that ramp up power. Now I changed it between 16 degrees on the motor timing because it comes default on 16 degrees. I set it to auto. When I set it to auto, I had actually more noise. It was running less efficient. So 16 degrees as default seemed okay. It's pretty good. Now if we take a look here, this is the zoomed in part right there. And it's, you know, it's not that bad. It's working pretty good. As you can see those dark areas right there. This is full throttle here. And this is when it's shut down. I'm having these nasty voltage spikes. But in reality, you're just up to like right here, which is, what is that? That's like a 7 volt voltage spike. But these ignore these for right now. We will be getting into these little spikes later on. But they are still pretty bad here, you know. Low ESR capacitor wouldn't hurt here actually. But overall, you know, it tested okay. I expected a little bit more, to be honest, but that modification you have to take that into consideration. If you find your quad just, you know, just acting weird or just jittering, or just the motor sounds really rough, and it's just, it feels like it's stalling, kind of like it's just like, I'll show you a quick video. Let's take a look at this. It should, something like this you should see. Then that's when you use your increase your RAM up power to see if that'll fix it. Alright, so you saw that. That's what I had to deal with in the beginning until I started playing with the BLHeli32 commands. However, I did keep the PWM frequency as default. It comes on 24 kilohertz. The more you increase it, the smoother the thing runs. But there's a certain amount, there's a specific limit where actually ESC won't even work anymore. So you'd have to drop back down. So the higher the PWM frequency you can get in BLHeli32 to work with your flight controller, the better. It's like adding low ESR capacitors in a way. So that's very good in that perspective. So overall, you know, the latency, you know, this whole quad, you know, some of the modifications, I didn't see any flight footage with noise. I don't really remember I saw any noise. So it could be filtered out through the flight controller, the PDB, as well as the VTX. So that could be the reason why. But overall, it could run a bit more efficient. So we're going to be taking this a little bit further later on Tuesday. Tuesday's when I get my power supply. So that's when I'll be able to really dig in this and just make it super efficient and super proper. Now, I'm not saying it's bad, and I'm not saying it's super good. This is just, I guess, the average level of ESCs out there right now. So don't forget, it's running a 2306 motor, so they're pretty massive. They do have a lot of amps and spikes because they're just massive motors. So that's really it. That's going to conclude it for this video, guys. I really hope you guys enjoyed the video, and please consider joining my Patreon, joining the mission, help me document everything I possibly can, and so we can make educated purchases as well as have the real hidden data. You could also use the affiliate links down there. You know, that'll help the channel greatly. Actually, it'll keep allowing me to bring more components into test. You don't even have to buy the same thing down the link. You could just click on it right before you make your purchase. It'll send me a couple cents. Everything adds up, and it'll go very good towards the channel. And well, that's it, guys. So don't forget to share, like, and subscribe, and I will see you next time. See you guys. Take care.